Okay, hello and welcome to my demo video for the final project in GAM475 at DePaul University. This video is largely for Professor Ed Keenan, but to anybody else who stumbles across this, I apologize. Okay, so let's get started here. We'll put up just a basic run of the program, get a couple of the basic features under wraps, see what we're working with here. Let's go. So okay, right here you can see just a basic camera here looking at a bunch of objects that are showing on the screen. Judging from the requirements, you can see there's a couple cubes here. There's 3 on screen right now. You can see there's 3 toruses, one way back here in the background, one moving across the back here, and there's one torus hiding behind this pyramid as well. There you can sort of see it peeking out. We'll get a better look at these things in a second. As you can see, there's also a bunch of pyramids here. You might wonder that I'm a couple cubes short of the 4 requirement, but if you move the camera here, which we have full movement of the camera, we can move left, right, forward, back. We can pan up. There's our extra torus up there. We can pan down, and there we go. We found an extra cube down there as well. We can also pan left and right. Actually goes all the way around. And then we're back to about where we started. Camera controls are move forward, move back with the arrow keys, left and right with the arrow keys, and the pans are all done with WASD to go up, down, left, right. Let's see, what else is there? There is multiple cameras actually. F1 will cycle through the cameras. You'll just get a different view of what we are. So this time we're above the camera. The first one sort of looking down at the whole scene. You can actually see all of the objects here spinning and doing their thing. And then I think I set up another camera to the right of the scene, so you get a little side view, see what's going on. You actually don't see every object here, but close. You're missing, I believe, 1 cube. And then I think we're back to the main camera. Also here you can notice the instancing capability of all of these objects. You can see that there are multiple pyramids with different colors, multiple toruses with different colors, multiple cubes with different colors for lighting. You also notice that there are different textures for each one as well. We can also change the shaders just by the press of a space bar, and you can notice that that takes away the light color. Now we just have our textured objects. We can even just look at the non-textured objects with just lighting, with just the face fill and the wireframe, just to verify that the other objects are turning as well. You can see our cube down there, and our torus up there is actually in wireframe, even though the ones in the background look sort of like they are filled in. We can even go check in on those to see. You can see that they're actually wireframed as it moves across there. So good. Okay. If we put our cubes back, getting a little lost here in the scene. Let's see. I don't even know where I'm at, but we could cut into the code and check out some stuff. So let me kill this demo real quick. Some other things we might want to point out is we do have a couple managers here. We have a graphics object manager as required that, basically just adds objects, draws objects, nothing too exciting. We also have a texture manager as well, which allows us to do all the various texture things. And we also have a camera manager, which again allows us to handle the multiple cameras in the scene. If we go to the setup for some of these objects, we can actually swap a texture out and see how easy it is to swap. Right here you can see the textures all being loaded into the manager. I just loaded the 4 that we had in class, plus an extra one, I guess. But you can simply just take one of these enums and swap it out into one of the models, and you can actually watch the texture change. So let's grab one of the moving pyramids and swap the texture out on that. So it was the floor texture before. Let's make it the rocks texture, and that's all you'll have to do to swap out the texture. Since we already loaded it in the manager, it's simply setting it onto that pyramid object, and we should see the pyramid object that's moving up and down used to have this floor texture here, but now has the red rock texture. We can get a better look at that, and we can see that the texture has in fact changed. Another thing to point out in the grand scheme of things here is you can see that there are some objects that are rotating around the x-axis. There are some that are rotating around the z-axis, the y-axis. You can see a wealth of movement here. Some things are rotating around multiple axes at once. You see this cube is just spinning around the y. This one back here is spinning around the y and the z. This cube here is actually just standing still. It is a cube, not just a square. You can see the side there, the perspective. You have pyramids that are moving, pyramids that aren't. Here's a pyramid moving back and forth, up and down, and so forth. So you can see that there's movement associated with all of the objects, and it's all instant. So you can set the movement on any of these objects, and it will move appropriately. Let's see, what else? What else? Okay, back. I took a little pause break to check my little cheat sheets of requirements. I think it's also worth noting that these objects in this demo are actually being loaded from a file. You can see we'll use the cube model, the pyramid model, for example. You can see here we have this create pyramid data. It's actually loading from a file. It's very similar to what we did in class with the converters actually just in the code here with that little toggle at the top, and you can see here is the code that's actually running. It's actually pulling the data from this pyramid.cdm file and loading it, loading the VAO that way. Let's see. Another thing we can start checking out is culling. If we once again pick one of these models, let's see, we can go into the cube object. You can see right here that we're actually culling against the active camera, which is what you'd expect, but it's hard to actually show a demo for what's actually being culled. So for the purpose of a quick demo, let's set all of these objects to actually cull against camera 1, which is one of our cameras in our camera manager. We'll save that. Let's do all the objects just to make the culling dramatic. We can swap that out, and we'll grab the torus object as well. Swap that out. We should be culling on camera 1 each time here. We can stop that demo. Run this, and actually what we should be able to see is if we turn this camera, let's say we cut off here, we should only see a couple objects now. If we switch cameras, we can see that there's actually only a few objects being drawn, much less than there were before. If we switch to the the side camera, you can see there's only a handful of objects here versus the over 10 that there were previously. We can move the camera back in place. Here we are, we're seeing most of the objects again. Cut to this, you can see there are the objects, the cube that is below the grouping of objects here, and the torus that is up to the top left, you can see are actually culled. And then one more example of that, we can zoom in really close here, maybe cut off all of those back objects. Let's see what happens here, and you can see. You can actually see here too, one of those pyramids is actually moving in and out of the frustum of the main camera, and thus getting culled. Aborted from draw. It's not actually being drawn unless it is inside the camera, and you can probably see that one coming in here. Somewhere there it was at the top right. Okay, let's see. Okay, took one more break. What I'm going to do for the last little part of this demo is actually flip this toggle on to draw our bounding spheres, and we can actually see the bounding spheres of our objects being drawn in the scene as well. There you go. You can actually see all the bounding spheres of all of our objects drawn. I could show you testing culling on that, but the demo is already getting long enough, so the true culling, the aborting the draw will have to do it. Over 10 minutes, I apologize for the length, but there was a lot of stuff to show, and I hope you enjoyed my quick demo. Thanks a lot.